Hey everybody, we're going to start with quiz review 2, problem number 1. Um, so I'm not going to write the problem on the screen, but I will read through the problem so you can just listen a couple times if you don't have it in front of you. It's a two-part problem. So we have an orange that's being thrown off of the Empire State Building. This orange is rolling horizontally at 28 meters per second. So there's the Empire State Building rolling horizontally at 28 meters per second. And we know that the building in the problem is 209 meters tall. So this height is 209 meters. All right, so that's basically all we know. We know that the orange is going to follow a path, something like that. And the first thing we're tasked to find, is the speed, really the velocity, Vf, at which the orange will hit the ground. So to do that, we have to find our individual pieces. We know that this side's always 28. We need to find this side, which is our Vfy. So just like always, we should set up our knowns in terms of our horizontal and vertical information. Horizontal, we know that Vx, 28 meters per second. We know that dx, we don't know. And we know that time is our bridger. Vertically, we know ay, this is always true, negative 9.81 meters per second squared. We know viy is 0 meters per second, and we know that our dy from the problem is negative 209 meters. Negative because the orange is falling downwards. So, part A, we have to find the final velocity, Vf. Part B is asking us to find this distance, which is dx, how far away from the building the orange will land. So, this will probably take 2 slides, but we can easily go through it. So, the first thing, we have ay, viy, dy. To fill in our triangle, we need to know what vfy is. So, that's one of our unknowns. And we're going to solve for that. You could do it 2 ways. One is find time first, then use the time, but we can also do it directly. So I'm just going to do it directly, saying that I know with my knowns, I have to use the equation vfy squared equals viy squared plus 2ay dy. Vfy is what we're looking for. We know that vi is 0, so 0 squared is 0. No need to write 0 squared, because that's still just 0. Times 2 times negative 9.81 times negative 209. When we get that into our calculator, 2 times negative 9.81 times 209 gives us negative 4100.58. So 4100.58 is our VF squared. We got to get rid of the squared, so we take the square root of both sides. And we're left with plus or minus 64.04 meters per second. Really, we know it's going down because this arrow is going down. So we know that's 64 negative 0.04 meters per second. Now that we have our 2 sides of the triangle, let me come over here and draw the triangle just a little bigger. 28 is our Vx over, 64.04 is our down. I don't have to put the negative here because I have the arrow pointing down for me. That's taking care of our negative. I've got to find Vf, so all I have to do is use Pythagorean theorem. 28 squared plus 64.04 squared, square root of that gives me the length of this side as 69, sorry, someone's pulling my driveway, 0.89 meters per second. So that's our final speed. The last thing we have to do to really classify this is find our final angle. And our final angle is found as the inverse tangent of our opposite side, which is 64.04, So here's our angle, opposite side, adjacent side, over 28. When you plug that in, inverse tangent, 64.04 over 28, 66.38. 66.38 degrees. So we have our speed, we have our direction. We just got to put it together for our final VF, 69.89 meters per second at 66.38 degrees, and our direction will be BH. So that's part A only. On the next slide, I will go through part B, so bear with me on that one. So remember this, you can pause it, write down any of the information. I'm going to have to redraw the H and V, but we'll get to that. So we're trying to find now our dx, horizontal, vertical, AY, negative 9.81 meters per second squared, VIY, 0 meters per second. Looking for a T, or might be looking for a T. We know our VX, 28, meters per second. We know, what else do we know? We are looking for a dx. We know from previous problem that VFY is 64.035, negative 64.04 meters per second. We're trying to find T. I could also use the fact that D equals negative 209 meters. A bunch of different ways we could do this. I could either do D equals VIT, dy equals VIYT, plus 1/2 AYT squared. And I'll do it this way. You could also, if you want to, make it maybe a little easier mathematically, VFY equals VIY plus AT, and solve for T that way. Really doesn't matter. But I'll do it this way just because this is our more often used equation when trying to find time. Negative 209, our VIY is 0, so this whole term goes away. 0 plus 1/2 of negative 9.81 is negative 4.905. So I'm just going to combine these two right away. 1/2 of negative 9.81, negative 4.905, times T squared. So this piece goes away. I get negative 209 equals negative 4.905 T squared. The reason I have to do this is I'm trying to find dx. I don't know T and I don't know dx, obviously. So in order to solve anything horizontal, we only use this one equation, dx equals Vx times T. But I don't know dx and I don't know T, so I need to find one of the other pieces in order to solve for dx. That's why I know I have to first solve for time. That's what we're doing over here. So these are multiplied. 4.905 is multiplied by the t, so in order to get rid of it, I have to divide by the 4.905 on both sides. That's what gets rid of my negative. So then 209, negative 209 over negative 4.905 is 42.61. That equals t squared. Same thing, we've got to get rid of the square. So we have to take the square root of both sides. It's going to give us a t equal to 6.53 seconds. Depending on rounding, yours might be 6.51. That's fine, no worries. So our t is 6.53 seconds. Now I can plug that in. And I know, now using this equation, I'm solving for dx. So my Vx is 28. My t, 6.53. And I'm going to get 28 times 6.53, which is 182.84 meters. So my horizontal range is 182 meters. Really 183. All right, so that solves problem 1. Part A and Part B. Part A, going back, if you look back toward the beginning, finding our final velocity. We got, I'm trying to do this from memory now, 69.89 meters per second at 66.3 something degrees below the horizontal. And part B, how far from the base will the orange hit? 182.84 meters. Again, if you have a couple decimals off, not a problem at all. So hopefully you got this. If you think you do, try it. It'll be very similar on your quiz. You'll have a very similar question. So keep at it, and good job.